You ever wonder what's really going on under the hood of your favorite app or game? Well, today we're going to pop open that digital toolbox. We're going to look at the fundamental building blocks that power literally everything, from your high score to your shopping cart. So let's dive right in. So it all boils down to this one simple question. How does an app remember anything? Your high score, your username, the stuff in your shopping cart. The program has to hold on to that information while it's running. And the answer, it's not magic. It's all about memory. And the very first tool we're going to pull out of our toolbox is, well, it's basically a storage box. In the world of programming, this is called a variable. This is the most fundamental way a computer remembers anything. It's what makes an app feel personal, remembering your name and not somebody else's. So what is a variable, really? It's just a named container in the computer's temporary memory, what we call RAM. You just give it a label, something like player score, and then you put some information inside. The key, and this is important, is that the value inside this container can change. That's why we call it a variable. And what's really cool is that this idea is universal. Different programming languages, like Python and Java here, they have their own special grammar for writing instructions. Programmers call it syntax. But look, the core idea is exactly the same. You're just telling the computer, hey, make me a box, name it X, and put the number 10 inside it. Simple as that. But what happens when you have a piece of information that should never change? Think about something like the value of pi or maybe a fixed pay rate. For that, we have something called a constant. It's kind of like a storage box, but with a padlock on it. You set the value one time, and the program makes sure it can't be changed by accident. Okay, so we've got our storage boxes, but think about it. You wouldn't store soup in a shoebox, right? It's the exact same idea in programming. You have to tell the computer what kind of information you're planning on storing, and these are called data types. Let's just run through the big three real quick. First up, we've got the integer, or int for short. This is your go-to for any whole number, positive or negative. We're talking player scores, lives left in a game, your age, just no decimals allowed here. Next, the string. Anytime you need to store text, like a username, a message, the title of a level, you use a string. And the computer always knows it's text because you wrap it in quotation marks. And finally, the Boolean. Now, it sounds a little fancy, but it's actually the simplest one of all. A Boolean is basically an on-off switch. It only has two possible states, true or false. Is the game over? True. Is the user logged in? False. This super simple concept is the foundation for all decision-making in code. All right, let's circle back to those constants for just a second. There's a really, really important reason to use them, and it's all about avoiding a common trap that programmers call magic numbers. So what is a magic number? It's basically any unexplained number that just appears out of nowhere in your code. Yeah, it might seem like a quick shortcut when you're writing it, but trust me, it creates a massive headache for anyone who has to read that code later, and that includes your future self. Take a look at this line of code. I mean, we can probably guess it's calculating something about taxes and work hours, but where did 7.25 and 0.15 come from? What on earth are they? Right? What do they actually represent? Is 7.25 the hourly wage? Is 0.15 a state tax? A federal tax? Who knows? Without a label, the numbers are completely meaningless. And just imagine the tax rate changes. You'd have to go hunt through the entire program to find an update every single time you use that magic number. It's a nightmare. And here's the solution. Look how much better this is. By creating constants named pay rate and tax rate, the code instantly becomes readable. It tells a story. And the best part? If the tax rate ever changes, you only have to update it in one place. It's clean, it's clear, and it's so much easier to maintain. Okay, so we've got our data stored away in variables. Now it's time to actually do something with it. And for that, we need our next tool from the toolbox, operators. Just think of these as the tools on our workbench. Operators are really just the special symbols that let us perform actions. Most of these from math class. They're what we use to add, subtract, compare, and basically manipulate the values that are inside our variables. You'll definitely recognize addition, subtraction, multiplication, and division. But that last one, the percent sign, that one might be new to you. That is the modulus operator, and it's surprisingly useful. All the modulus operator does is give you the remainder after you do a division.
So 20 modulus 7 is just a fancy way of asking, if you divide 20 by 7, what's left over? Well, 7 goes into 20 two whole times, right? That gets us to 14. The leftover amount is 6. This is super handy for things like, say, quickly figuring out if a number is even or odd.
Now this is a big one. It's a crucial difference that trips up every new programmer. A single equal sign is for assignment. It's saying, put this value into that box. But a double equal sign is for comparison. It's asking a question. Hey, are these two things equal? The answer to that question is always going to be a Boolean, true or false. Mixing these two up is a classic programming bug.
All right, let's put this all together now. We've got our materials, those are the variables. We've got our tools, the operators. But a pile of wood and a hammer doesn't make a house, right? You need a blueprint, and in programming, that blueprint is called modularization.
Modularization is just the big idea of breaking a huge, complicated problem down into smaller, much more manageable chunks. So instead of writing one giant, messy program, you create these little modules that each do one specific job. This makes your code so much easier to read, to test, and to fix. It's the whole reason your favorite apps can get updated with new features without breaking everything else.
And most programs follow the same logical flow, which we can break down into 3 main stages. First is housekeeping. This is where you set up your variables and get everything ready. Next is the detail loop. This is the real core of the program, where all the main work actually happens. And finally, you have the end of job tasks, where you might display the results or save your data.
To see how this works in the real world, let's use the example of baking a cake. The housekeeping is you gathering all your ingredients, preheating the oven. The detail loop, that's the main action, mixing everything together, pouring it in the pan, and baking it. And the end of job task? That's letting it cool and, of course, serving the cake. See? It's a logical, step-by-step process.
So, there you have it. That's the basic toolbox for any program. You've got variables to store information, operators to work with that information, and modularization to act as a blueprint to keep it all organized. So the final question for you is this. Now that you have the toolbox, what everyday task in your own life could you turn into a blueprint? Give it some thought.